Have you ever looked up at the night sky and wondered what secrets the stars are hiding? We see them as tiny, twinkling points of light, but some of them are the most extreme and bizarre objects in the entire universe. Today, we're diving deep into one of my personal favorites, the neutron star. Get ready, because your mind is about to be blown. So, what is a neutron star? Imagine a star much more massive than our own sun. It lives its life for millions or billions of years, fusing elements in its core, shining brightly. But eventually it runs out of fuel. For these supermassive stars, the end isn't a quiet fade-out. It's a spectacular, universe-shaking explosion called a supernova. The outer layers of the star are blasted out into space, creating beautiful nebulae. But what's left behind in the center? The star's core collapses under its own immense gravity. This collapse is so powerful, so violent, that it overcomes the forces that normally keep atoms apart. Electrons and protons, the fundamental building blocks of matter, are literally crushed together to form neutrons. What you're left with is a city-sized ball made almost entirely of neutrons, packed together as tightly as physically possible. This is a neutron star. Now, when I say city-sized, I'm not exaggerating. A typical neutron star is only about 12 to 15 miles, or 20 to 25 kilometers, in diameter. That's small enough to fit inside the boundaries of a major city like New York or London. But here's the crazy part. Packed into that tiny sphere is a mass that's 1.5 to 2 times the mass of our entire sun. Let that sink in for a moment. All the material of our sun, which is over 1 million times larger than Earth, squeezed into a ball you could drive across in under half an hour. The result is an object with a density that is almost impossible for our minds to comprehend. This is where we get to the headline fact, the one that sounds like science fiction. If you could somehow take a magical, indestructible teaspoon and scoop up a tiny bit of matter from the surface of a neutron star, what would it weigh? Brace yourselves. A single teaspoonful of neutron star stuff would weigh approximately 6 billion tons. Let me try to put that into perspective. 6 billion tons is the weight of about 900 Great Pyramids of Giza. It's the weight of the entire human population of Earth, multiplied by about 10. Imagine every single person on this planet, all their cars, all their houses, all their stuff, and you're still not even close. All of that mass, concentrated into a volume smaller than a sugar cube. The gravity on a neutron star is just as ludicrous. If you were to drop an object from just 1 meter above a neutron star's surface, it would hit the ground in a single microsecond, accelerating to a speed of over 4 million miles per hour. The gravitational pull is about 200 billion times stronger than Earth's. You, as a person, wouldn't just be flattened. The tidal forces would be so extreme that they would rip you apart atom by atom before you even got close. Your constituent atoms would be stretched into a thin stream of plasma, raining down onto the surface. So how does this happen? It's all about empty space, the everyday matter we see around us, the chair you're sitting on. The air you're breathing, even your own body, is mostly empty space. You have the nucleus of an atom, and then you have electrons orbiting it at a relatively vast distance. If an atom were the size of a sports stadium, the nucleus would be like a marble in the center. The rest is just empty volume. A neutron star gets rid of all that empty space. The immense gravitational collapse forces the electrons into the nucleus, merging with protons to create neutrons. Everything is packed nucleus to nucleus, with virtually no space in between. The result is what physicists call neutron-degenerate matter, one of the densest forms of matter known to exist. These objects are not just dense. They're also incredibly hot, and they spin unbelievably fast. When the massive core of a star collapses, it conserves its angular momentum, kind of like how an ice skater spins faster when they pull their arms in. A star that might have taken days or weeks to rotate once can spin up to hundreds of times per second after collapsing into a neutron star. Some of them, called pulsars, shoot out beams of radiation from their magnetic poles. As the star spins, these beams sweep across the cosmos like a lighthouse, and from Earth, we see them as regular pulses of light, which is how they were first discovered. It's a strange and violent universe out there, and neutron stars are one of its most fascinating creations. They are the leftovers of stellar death, cosmic fossils that push the laws of physics to their absolute limits. They show us what happens when matter is subjected to forces we can barely imagine. The next time you think of something as heavy, remember the neutron star. Remember that somewhere out there in the vastness of space, there are objects where a single teaspoonful weighs more than a mountain range. It's a humbling reminder of just how wild and wonderful our universe truly is. Thank you so much for joining me on this journey to the edge of physics. If you enjoyed this and want to explore more cosmic wonders, make sure to hit that like button and subscribe to the channel. Let me know in the comments what other mind-bending space topics you'd like to see next. Till then, keep looking up.